So, I think we're just about to start for today, the first hub session, Smart Metering 2 in this theater. My name is Henrik Göthberg. I work in Vattenfall, and I actually thought I'll ask the speakers to come up on stage, just so you get to see who we're going to meet today. And yeah, you can start. What's your name?
Cem Gurpinar. I am the technical consultant for the Oil Gas Companies Association in Turkey.
Good morning, everybody. I am Artis Rebnex from Sadal Stikels, distribution system operator in Latvia.
Good morning. I'm Julie Pinel. I'm working in the strategic department of GRDF, the French DSO, and I'm in charge of smart gas grid development.
Good morning. I'm Alexandre Vial and work at GRDF with Julie, but on the device part with AMR devices.
Good morning. My name is Andrzej Szyb and I work for Tauron Distribution, the Polish DSO company.
Yes, hello everyone. My name is Rafał Pawlus. I work in Future Purchasing IT company, and I'm working in the Smart City division.
Thank you. Good morning, everyone. Headphones. Happy to be here with you, and thank you for joining us for the panel. My name is Livia Rosu, presenting Home Grid Forum on the Industry Alliance for Telcos, Service Providers, and Silicon Vendors.
So, I thought I'd start with a very short introduction, and then we'll have the first, thank you guys, and then we'll have the first presenter on stage. So I have one experience from going to conferences and exhibitions that I want to share. And it's something that Socrates could have said. The more I learn, the more I know I need to learn more. Or, you know, it's the questions ultimately that I come home with that is the most valuable. So I go to conferences thinking to get all these answers, but the main strengths I get is I understand the questions I need to ask at home better, so I can more clearly frame what we need to do. So, I was hoping, or wanting to help you by putting three main questions on the table that I think we should reflect on when we listen to all these presentations and when we listen to the panel discussion. The first question I have that I'm trying to understand is, when we talk about smart metering, what is the fundamental business models and roles that will work in this context? So what's the ecosystem around the smart meter? So think about that and place these different talks in this context. So what's the business model? What are we doing? What's the value we are creating? Who's going to pay for that value? Who's going to do the investment? What's the business model? What's the roles? That's the first question I have. The second question I have, what of all these new technologies, innovations, AI, edge intelligence, analytics, I don't know, blockchain, all these things that we've heard about in this conference, how are they moving into this ecosystem? Where should we use them and where will we need them? So when we are working in the smart metering space, we might have started this journey many years ago, and we actually need to frame ourselves to be future-proof, or we need to even think about we need to add things to the idea we had from 5 years ago. So what I'm trying to say is, all the technologies, all the innovation that is truly happening, how is that affecting, or how is that being incorporated, or why should it be? So have that thinking about this. And then the last question. So with this knowledge or this business model and these ideas, how would we now define and frame the smart metering scope? So smart metering, when we talked about this 10 years ago, it was framed in one way. Right now, it's framed in one way. How is it framed in 3 years, in 5 years? So, reflection for today, this is my introduction. What's the roles and business models we see? What with all this innovation and technologies, how are they affecting? How should we incorporate that into our thinking? Number 3, how do we then need to frame the scope of what we're doing? Okay, So with that short introduction and warming up your brain to start receiving the presentations, I would like to ask the first presenters on stage.
Hello everyone. Henrik, thank you for kind introduction. We will give you short information about our project we called Advanced Metering Data Management Platform, considering the aspect of data exploration and analytics. As we are running the project in the consortium, we will share the two perspectives of this activity. First is from the DSO perspective. I represent Tauron Distribution, the Polish DSOs operating in south of Poland. And my colleague Rafał will represent the IT company perspective, our consortium member. In Poland, all the DSOs have run some pilot or initial rollout in smart metering area. We in Tauron have several such projects as well. The biggest one is running on the territory of Wrocław city, where we completed a large 4-year smart metering rollout with over 370,000 metering points. We have 3 types of meters on board. We have PLC technology and OSGP support. For this, it will try to work in fully interoperability model. At the same time, we run the rollout of balancing meters in Poland. It's pretty close to be completed. And these 2 deployments bring large volumes of different data for DSO. This data could be useful. We have a typical benefits behind these rollouts. Of course, we can remotely read our customer meters. We can bill based on the real consumption. We give the customer possibility to monitor their consumption via web app or mobile app. We can even do this within 15 seconds through the MBUS protocol recently. So this is the basic benefit perspective we have, but we are strongly convinced that there are far more to come. So we addressed one very important question at the beginning: how metering data analytics could bring more value to DSOs. And we got deep dive into 7 identified areas that we are doing our R&D work. First 2 are analysis of available metering data from smart metering meters and from balancing meters. This is the core set of data that can lead us to further analytics. There are very important aspects are data validation, estimation of flux of data, or some forecasting. Once we have this coherent base for the one analytics, we can consider some more aspects like reliability incidents, like SAIDI. We can analyze the impact of reactive energy at the balance difference. Our focus was only the new types of load models, analytics of simultaneity factors for connection purposes and grid development purposes, and lowering the balance difference, digging about the illegal consumption of electricity. Once we discussed it a little bit, we found that there are also some challenges ahead. We identified them. First of all, the models and analytical tools have to be developed to be used in such cases. We have an aspect of data processing visualization to make it usable for the company, for the users. We are entering the scale of big data, so we are expecting more rollouts. So we have to have scalability in mind doing this project. We have to take other data sources on board to have full view of the system. I mean the asset management system, outage management system as well. It's some way it should be considered as a whole data set for the analytics. And of course we should have in mind the security by design, talking about privacy, talking about the safety regulation and directives about the personal data. And this brought us to the R&D project. We set a goal that it's the goal of the project is to develop the advanced metering infrastructure management platform to deliver added value for DSO purposes. We have, as the DSO, found the partner, the IT partner, Future Processing. We made a consortium. Once we identified the challenges, we knew that we have to have some scientific support, so we engaged two very good universities, technical universities from Poland. It's Technical University from Opole and Częstochowa. They are supporting us. In this model, we applied for European funds. We got it successfully. We have a co-funding from European Union, from the National Center of Research and Development. As we are doing R&D project, we have typical phases. We started with industrial research last year, where we have aspects like functionality, performance, architecture, safety, mathematical models, analytical tools, and we are operating in lower technology level index, TRLs. Then we entered the experimental development phase. We've got a real data inside. We are implementing the model and analytical tools from the universities to the real IT system. We are preparing for data processing and visualization, and we're building the prototype development and testing. In the final stage, we will implement the project results. In our model, is something that distinguishes it. Because we are working in consortium, we will share the IPR for the solution. So we have two ways or two streams of project results implementation. First, we take the system into our activity, our own distribution, and we treat it as a process innovation. And secondly, our consortium partner, Future Processing, is implementing the product into its own activity. It will be product innovation. So, speaking about our consortium partner, I will leave the floor for Rafał, and he will speak more about the IT perspective of this project.
Applause. Thank you very much, Andrzej. So I'm going to say something about the big data and IT perspective on this project. Andrzej, my colleague, present information about the business context and 7 main areas contained within it. So what about the big data? We're gathering from data perspective, we're gathering data from Smart City Wrocław, this kind of data, 370,000 meters, reading per days, and monthly date increase. So when we saw the volume of data, we started thinking about the big data solution. And from the ITC perspective, it was a challenge to create and develop a secure and scalable cloud-based solution, which help us to provide the business needs that we've been talking about. So when we knew that we need to create the business solution, the first task from our side was to find the cloud providing solution. So we chose 4 criteria based on which we decided that we need to find our cloud provider. One of is security, because the data we are processing are very sensitive. So we need to make sure that our data is secure, they won't lose, and they won't be protected by the cyber attacks. The next criteria was open to business. As Andrzej mentioned, we will be implementing our solution in other companies through the commercialization. So we needed a partner who will understand our business needs. The next criteria was stability. We needed a partner who won't disappear in the next 2, 3, or 4 years, because this project we are right now working on is very important for us. So we needed someone who is stable from organizational point of view. The next things we've been looking for and the criteria is big data tools, because as you know, we're working in research and development project, and one thing which is certain is that we will have many changes. So we know that during the research and development project, the changes will change. So we used vast range of big data tools that help us to adjust for our needs. And when we have this criteria, we're looking on the market and we find our provider is Microsoft Azure. And the next step was to create on high-level architecture how we're going to proceed this data. And we can point for 4 stages. First stage was to download all the data from on-premise Tauron distribution data sets. And next stage was to create warehouses for the data, like current data, historical data, and proceed data. The next stage, which is right now, it was most important, is to process all the data, because we've been given mathematical models by the universities, and we need to process this data through the algorithms and machine learning. And right now we're in the middle of creating the web application which help us to visualize our data through map, tables, and all that kind of stuff. And we would like to share with you on one case we've been working on currently. It's related to the reduction of energy losses. And on the first stage of our project, industrial research, we've been focusing on 2 methods. One of the methods is related to based on simulation test, including voltage drops, and the next method is based on the analysis of the electricity balance. At the end of this verification, unfortunately, both methods have delivered unsatisfying results. And what was the results? In some cases, the voltage of the connection was higher by approximately 1 to 2% than the voltage on the individual phases. The next result was the difference data granulation for different psychical quantities, like energy is 15 minutes and voltage is 10 minutes. And the difference between the currents calculated from the voltage drops on the power grid elements and the current calculated from the power was consumed by the loads, which was very large. But we haven't given up. And when we saw that results, and we knew that we won't be able to find a solution to identify illegal energy consumption, we haven't given up, and we're trying to move and find other approach. And we can divide our approach right now in 2 ways. One approach is related to the statistical models, and the second approach is related to the machine learning. And briefly talking about the statistical models, we point several ways how we can detect illegal energy consumption. One of them is the visualization of time series to activate the power and events recorded by the meter, detection of low or excessive matter reading using qualities, and any kind detection on non-typical daily energy consumptions. But what right now we currently focus on our work is related to the machine learning, and especially with the method, it's time series analysis by grid long short-time memory. And we've been working on the data from 1 year, which have 100 detected illegal energy cases, when we're trying to teach our algorithm how to detect them. And the latest test shows us that our algorithm can detect from 72 up to 82% of illegal energy losses. So right now we are developing it, and we're trying to find more way, and this outcome give us good information for the future. Andrei?
Just to sum it up. Sure. Short summary, we are now in the middle of experimental development works. We are expecting that the project will deliver the final result in mid next year, and then we start to implement this solution into our work. Now for sure we can say that there's a lot of value in this data that we have already from the historical perspective. The insight and knowledge can be gained from this data, can be used for some business, many ways of business perspectives. Complex analytics refers to use of advanced algorithm methods should be on board. We have certain levels of volumes of data to have in mind. Anyway, Poland is on the stage where the bigger scale of rollout smart metering is expecting. Last 2 weeks ago, I think, the amendment to the Polish energy law was announced. It's in public consultation, and we have strictly direct goal to reach 80% penetration until 2026. Right now we have between 8 and 9%. It's still some challenge, and we are also establishing the market model with the central hub collecting the processing data. Our TSO will have to establish the independent meter operator, and it has to be done until 2022. So from our perspective, it's very crucial to think about the scalability to develop the solution that could be used in 3 years. Again, referring to your questions from the introduction, Henry, it's also very important to find what is the role of the DSO in the market, where we should stop our activity. Is it the meter or behind the meter? And I'm looking forward to discuss it during the panel session. Thank you very much.
Thank you very much. So we have time for some questions. If you have been here for a couple of days, you have seen this. So it's a microphone that you can throw. I want to have this at home. So do we have any questions in the audience? Anyone wants to ask any questions? We have one here. Are you ready?
Yes, that's true. Well, right now we are currently developing one of the machine learning models. It's a long short-term memory. We've been focused on trying to detect illegal energy consumption. And right now we just started this method, and we just briefly focus on how we can use machine learning to help with our business case. So you're interested about the business or about the technical information? This is going to be hard about the machine learning to present. Maybe I can swiftly trying to go back to my presentation. Below here, maybe like this. These two graphs show the machine learning from time series analysis by Grid LS team, and it's showing the prediction about the legal and illegal finds of illegal energy consumption. And as you can see right now, we have the information how many good prediction we have, our algorithm find, and how many bad prediction we have. This is the confusion matrix. So at the end of the project, I hope in the next year I can say some more about how this algorithm work properly. But right now we're trying to teach him how to be more efficient. And the next stage in our work is to gather information from Tauron distribution, because we we receive information from our distribution about the illegal energy consumption. We give this information to our algorithm, and they present this kind of information. And the next stage is to give this information to Tauron distribution. Okay, look guys, okay, this is our data. Can you go and check on this place, is this true that this is illegal energy consumption? And from this data, we can teach our algorithm, okay, look, you have correct answers or bad answers. So right now we need to have several phases to teach the algorithm. So it's cooperation between the machine learning and between the Tauron distribution right now.
Fantastic.
Okay.
Any other questions? All right. Are you ready?
Thanks very much. I just have a question about, are you involving the actual customer?
Actually, this solution is orientated to DSO's internal needs and should bring some value to basic DSO's procedures and processes like connection, grid deployment, grid development, grid aspects. So this is rather DSO oriented.
So it's very much improving efficiency in processes. So there are other analytics on how you want to have your service, but that's not this project.
But of course we have the customer on the horizon, because improving our efficiency in our core business work, we improving is reliability, for example, of our grid service. So the customer also needs it.
All right, any more questions? We have time for one more question, I think. So then I will take the time to ask one question. When you have done this project now, when you have started up and you have gone through these phases, if you want to share, what do you think has been one of the more critical considerations to make it happen or to move forward? What you know, so we learn.
We made one very tricky decision. We started to work on real data inside, because it's R&D project. It's the place for such aspects, but it's a very tricky thing, because we had to bring this data into one place to have it coherent between metering data, asset management system, and outages management system, to to make it work and to make the proper conclusions from this data and to manage the ISO. It is still a very challenging thing for us.
Don't underestimate the data management topic when you bring different data sets together and try to work in one model to even have a set to do algorithms on.
Yeah.
That's a good learning. Don't underestimate that. Okay, I think we stop there. Thank you very much.
Thank you very much.
And I would like to introduce the next speaker here. I think frame it yourself is the easiest.
Yep. All right, good morning. Okay. So I hope everybody hears me well. My name is Artis Revneks. I am from Distribution System Operator in Latvia. And this morning's story is more about the good practices and lessons learned that we have picked up over the multiple-year rollout of smart metering project. To start, here is an overview of our vision of what a digital and data-driven distribution system operator is, the core basics. And today, I'm going to focus more on the actual smart metering stuff. So basically, a bit lower layer stuff, not including the data management and analytics and machine learning and all that nice, cool stuff. So this is our business and overall numbers. So the most important number is that we are a relatively small distribution system operator in Europe, in Latvia. So we have a little bit over 1 million metering points. And up till now, we have already rolled out approximately half of them. And with this half, we're actually accounting for more than 80% of the consumption. So if the saying is true that 20% of effort gives you 80% of the result, then we are there. We have done 20%. So next step is 80% work and only 20% result. And we'll see about that. But we have to finish by year 2022. So we're on the road to that. Everything right now is according to schedule. And very interestingly right now that the readout rate that we get for our smart meters is quite high, as you can see. Currently, it's 98.6% that we can reach actually. So, but our DSO is really they set very high goals, as you can see. So by year 2022, we have to strive for 100%. And that will be a challenge for sure. As you can see that based on the average DSO readout rates, we are a bit higher than that. So I will get back to that in a while. Other very significant number that I want to share with you today is the approximate investment for our smart meter rollout. As you can see, it's a bit more than 1 million meters. But the total amount of investments right now, including the initial hardware investments and also operational costs, it is estimated to be below 40 million. That would put price per unit between 30 and 40 euros. And according to the latest study, it's well below the average point. So I would just want to point out the efficiency of this model that we are now currently implementing. We have switched technology. We have switched our tendering process, and that is that could be the main goals for me today to give information about. So why do we do that? Because smart metering projects usually are very very costly, and not all countries want to implement 100%. We see that the main benefits comes from the convenience that our customers have. That also improves our relationship with the customer. We believe that every customer should have ability to choose from vast variety of energy products that suppliers can offer them. They of course offer these products mostly based on our data, so it's our job to provide them with the data. So hourly billing is paramount, basically. Also, another topic is energy efficiency, and not only that the customer can change his behavior to save energy, also can according to this data, it can choose different energy market product. But in addition to that, also we see that we can become more energy efficient, so we don't have to visit meters anymore. Also, we don't have to deal with the debitors, and we don't have to perform switching operations on site. So that also saves a lot of money for us, and we become more energy efficient. And of course, quality of the not only quality of electricity supply, because of course we can manage outages more efficiently. We get the outage alarms, so we can manage that. Also, we keep track of the quality of the supplied voltage. So that is also a big benefit to customers and also to us. And with the technology that we have chosen, there's also benefit for our grid quality. Yeah. So how do we do it? We are quite small distribution system operators, so we're very time and resource constrained, and it's really hard to do large projects, do large innovation projects from scratch. So we focus on really efficient, extremely efficient, small-scale pilot projects that we have to test out the technology. So here is an example for the moment that we changed our technology, when we switched from the mobile network operator managed communication to the power line communication. We had 4 companies with very small-scale pilots, 100 to 120 meters each. We rented out head-end systems to also gain a bit of knowledge about the software involved there. And we installed them in very challenging areas. So other projects have failed there, or other technologies have difficulties there. So that's where we installed these G3 PLC pilots. And we normalized the results, and we looked at each and every site separately to come to the conclusion and final decision to be one of the first DSOs in Europe to roll out a G3 PLC technology with FCC frequency band. So, and we did that in 2016. And if you remember, 2015 was when the G3 PLC was certified. So that's it. That was a big gamble, but we felt confident enough to proceed. Of course, when we do this switch, it involves a lot of risk. So here's how the main things that we kept in mind to keep the risk in check. So one thing that is also a risk itself, but also quite a kind of remedy, that we already have 4 different manufacturers for our smart meters. As I mentioned, we have different technologies. Also, we have different manufacturers. Basically, we're tendering each other year for a limited amount of deliveries for smart metering. So if something happens with one manufacturer, it does not affect the whole smart metering rollout, and also the operation does not disrupt the operation fully. Also, we of course implement keep in mind security. So we implement of course encryption and authentication goes without saying. Also, we fully use the opportunities that the technology is providing. We monitor our network, monitor traffic, and use alarms for, as I said, outage management. We do a lot of cooperation with local CERT teams, and not only that, we're also a member of European Network for Cybersecurity, and we do a collaboration with the DNVGL also for consultancies and to keep us on the right tracks. And we do invest in training, so security training, operations training, in CERT trainings and other European level trainings. So here is a brief overview. So we started out 2014 with the manufacturer with the PLC technology mainly. Then, as I said, we tender each other year. Basically, the tender is announced each year, but we revise each other year the tender specification. And 2016 was very relevant because then we switched not only technology, we also switched the way we tender. Our approach to basically testing, compliance testing and acceptance testing. So the latest tenders, you see the tender winner. So 2016 is when the Chinese companies went in market quite aggressively. So this is our tendering structure that I wanted to share with you. So we have a tender winner that has 12 weeks to prepare a working prototype that we can test for compliance to our requirements. So they come to us with a prototype, usually 20 to 30 devices that our team of testers can use to define the maturity level of the participant. So this can end in 2 ways. You can pass or you can fail. So basically, if you pass, then you have 12 more weeks to produce the first batch and deliver to us. If you fail, then we sign the same testing agreement with the second place and perform this again. Unfortunately, we don't do that additional iteration. So if you fail with the second tender place, then it's a completely new tender. So, but this is just to keep the risks in check, so that we don't sign and invest in a completely immature solution. Here is an overview of how we're doing this year. So, as you can see, that readout rates are very stable. So we see that the testing that we do and also the technology change has really paid off. We see that very stable graph. Keeping in mind that the meters are still being rolled out. There are more and more meters. Of course, we're running parallel the cleaning, so the cleaning operations, so we can manage to keep this number steady. So to conclude, our main benefit from all this is that we can select our partners before we make investment. So we can see their maturity level, we can see technology, we can see how it's implemented. If we want to change technology, then it's possible to do that. It's possible to gain the confidence to do that, to change systems, to change technology, to change approach. And here we went for different small projects where you can really gain this knowledge and gain this confidence. What has proved with the numbers that we saw with the investments that incremental rollout process, it really pays off. And we see that we have become very efficient. We can revise the tendering process each year, each other year. We can revise the requirements. Also, we can check what's going on in the technology business. But there are challenges, and the main challenges is the strain on the staff. So smart metering business is not very large, it's specific. So talent there is not very easily acquired, so we have to keep that in mind. Also, when it comes to testing, we have only 20 working days to fully go through the requirements, fully go through the testing scenarios. So it puts a lot of pressure on the team. And also this requires a high level and really strong project management. Another challenge is how do you define the key performance indication when you have the support phase. So you have to keep in contact with your supplier. You have to help your supplier to improve. You have to also work with the vendor very proactively to keep the KPIs in check, and also define the right KPIs that really brings you the most of the benefits. And yeah, I already touched the collaboration with suppliers. That is a huge topic that one must keep in mind when approaching this way, because you will become really deeply involved with the solution, with the product that they have delivered to you, and you are equally responsible for the operation, for properly operating this solution. So thank you very much.
Thank you very much. So we'll start with some questions on the floor. Look at this, one more.
Thank you. This is
This is
the collaboration with the supplier.
I like this collaboration. Fantastic. Wow,
Thank you.
that's cool.
Thank you.
Do we have any questions on the floor? Any questions?
Mm-hmm. Yep. Exactly. Yep. All right. I will try to try to remember the question. So about the data that we get day to day, our main focus is, of course, billing. So for now, default billing in Lavia is monthly billing, but we are really pushing forwards for hourly billing. So that is right now hourly data. We have also availability to provide customers with a shorter intervals of integration, like 15 minutes, 10 minutes, 1 minute. So that's also that we're looking at. About the alarms that we have. So we have a link, we have an integration between our geographical information system. So our dispatch center knows when the outages happen, even with the PLC. So if you keep at least one GPRS or LTE modem at the end of each feeder, you can pretty much get a good view what is going on each feeder. And also they're using this for, actually there's a number of use cases, but two of them are managing the outages and also then managing the switching operations in the grid. to see whether it has worked or not worked, like the restoration after defaults. And what was the last question? Sorry.
The third question was the communication, how it would cater to the other smart grid projects.
Yes. So with the what we see with the G3 PLC is that it's based on IPv6, and it's one of the main pitches are the IoT. So we see that this is our grid, this is our communication that we control. So we can not only use it for a smart meter, we can use it for sensor network, we can use it for other things, maybe with different bandwidths, maybe with different private networks within the G3 PLC network. I see that for metering it works really well. For other projects, for critical grid operations, of course, we have to look elsewhere because of course, if the line is cut, then there's nothing left for you. But it falls in pretty nicely if we keep metering operations and data gathering and the customer, the use cases for customer information separate from the grid operations. So we don't intend to manage mission critical infrastructure with the with PLC. No, that is the good last mile solution.
Excellent. Any other questions?
Yeah, we do it internally. We use collaboration and for training and for consulting. But all the pen testing, all the requirement checking and requirement writing, we do it in-house. Yes, we feel that that is something a bit sensitive to outsource right now, and we see that with this approach, as you can see, we're really deeply involved in compliance testing, so we really know what makes this product tick. So we are in a good position also to assess the cybersecurity aspects of the whole solution. So we keep that in house, but we do the training and we do consultancy outside, of course. Yes.
Excellent question. Any other questions? We have time for maybe one more question. Then I will ask a question. You highlighted to me a little bit before that you felt in some ways when you have talked to your colleagues in Europe that you had some differences in approach. Maybe this is all that you talked about with the tendering, but how did you experience the difference yourself, or if you would sum it up?
Yeah, if I have to sum it up, the main difference is that there are very different approaches, and I'm not saying that ours is the best. It's that something worked for us, and I have seen other approaches with the auditing of vendors and outsourcing testing and very many approaches. But well, I have not discussed with anybody this compliance testing, really, and this, I think that the most unique part is that we keep that in-house. So we keep this knowledge, and we're more, we keep more knowledge to us. Yes.
And you maybe see that as a critical factor here, because when we grow this into being, future-proof wherever this is going to go, it's going to be so hard to grow on that if you not have really deep knowledge on what you have done.
Either you write really, really, really perfect requirements stating everything you want for 10 years, or you can revise these requirements and keep all the know-how in-house and then manage yourselves.
Perfect ending. Thank you very much.
Thank you.
So, Kem, please, our next speaker from Turkey.
Good morning, everyone. My name is Cem Gurpinar. I am the technical consultant for Gazbir Association. Gazbir is all gas companies in Turkey. It's an association of all the gas companies in Turkey. And just to give you an idea about Turkey, we are around 80 million people. We have consumption of gas close to 60 billion meter cube. And we have 40 million electricity meters, around 40 million water meters, and around 15 million gas meters. I'd like to give you a little bit an overview about our natural gas distribution network. The grid, the national gas pipeline is connected to a RMS A stations, we are calling it. The A station is going down from 70 bar down to 16 bar, and it is connecting to a ring, and then eventually going into the RMS B type stations. These are the reducing stations, and together with the measurement stations, and they are feeding the residential areas with service boxes, which is going down to 21 to 300 millibar, and also they are feeding to the industrials and also feeding to the main industries from the B-type stations, and they can go up to 20 bar. When we are looking into the communication network infrastructure, we have a data, we have a SCADA system, and all the gas chromatographs, flow computers, everything you think is on the net, like the filters, all the equipment has been, all the data is gathered by the SCADA, and this is all the information is gathered and all the information is processed. We do have a redundancy system. If one fails, the other one takes over, so there is no communication or there is no data processing loss in the system. We have an OPC server, and then it is independent of any upper software language, and it's an universal communication protocol. SCADA application, all the Citygate stations and all the A-type stations are under SCADA, and they are also visualized, and we can see their working, and you can see their processes, and you can get all the data through them. If there is an emergency, for example, you can see it on the data on the SCADA system that there is a leakage on the pressure, and you can immediately take action on that. We do have 2D, 3D mimic diagrams, and all the stations are examined, and you could see any equipment, the reaction of any equipment on that. All the data is recorded in database and used in various operations, and we do have a data visualization. It is easy to graph the data for the cross-checking and comparison, and if there is an abnormal situation, it can be easily detected. We do have alarm and mobile system. In case of an emergency, we can find out all the data coming into the data through the data system to the operator and also to the people on the field. They get the alarms and the visualization on their mobile telephone with an SMS. And the next topic is we wanted to include the smart meter with the high pressure calibration, because you can have a very good smart metering. I mean, you can get all the data crunching, you can do everything, but if your meters are not measuring properly, I mean, still you are losing a lot of gas. So this is why, as Turkey and as Gazbir, we decided to invest into the high pressure calibration, because one must know that up to 2016, the meters has been calibrated, especially the large meters, about 4 bar with air. But now the requirement is also use them doing the calibration at the operating pressure. When you are making in the operating pressure, as you see from the graph, you see that there are some uncertainty differences. So, and we also looked into the 600 meters analyzed in the 10 years. It is because of the mechanical wear and tear and also a little bit dirt on the gas. You see the uncertainty level going into different ways. Basically, calibration market has 3 segments. One is the high end, which is the big meters, the mid segment, which are the industrial meters, and low end, these are the delivery stations. So we are dividing the market entry and what are the drivers. What is, because there must be also a feasibility behind that. That is the increased demand for gas, number of new transnational pipelines, number of meters to be calibrated, somehow determine the feasibility of this big investment, because high pressure calibration facility is a big investment. Importance of the gas balance, why we are doing this in Turkey, because all the gas companies and also translate, because Turkey being the hub, we are getting gas from Azerbaijan, we are getting gas from Iran, from Russia, and now there is a new pipeline being built from Azerbaijan to Europe. So it's very, very important the right calibration. It is very important the right measurement. So for that reason, we are doing extreme care with the smart metering, together with the equipment being on the perfect calibration. We did an analysis of the gas meters about, and also we also checked how many meters we have in the field, how many has to be calibrated, and the cumulative gas meter numbers. After evaluating everything, we have actually two options. One is in having an open loop high pressure calibration facility. When you're talking about the open loop high pressure calibration facility, this is the gas is flowing from the through the facility and going into the sink and is delivered to the city. This is one option. And as far as our design, because you cannot cover all the meters, but we try to cover like 90% of the meters already placed in Turkey. So we needed a maximum capacity of 140,000 meter cube, and it will be an ANSI 600. It's a high pressure test facility it will be, and the operation will be from 8 bar to 55 bar. So with this range, we're thinking to cover all the meters in Turkey. Also, the second option, having a closed loop. In the closed loop option, you are not getting the gas constantly from the pipe and then delivering it to the city, but you are getting a gas and then the gas is in this calibration facility and you are running it for every meter, for every pressure needed. And for this closed loop facility will go up to 80 bar, and it will be 10,000 actual meters, and it will do the calibration of 2 inch, from 2 inch up to 16 inch. Of course, we have not made a final decision yet whether the calibration facility will be open or closed, but both of them has advantages and disadvantages. Open loop is less OPEX cost than the closed loop, because open loop, closed loop has, you have to have a pressure, you have to increase the pressure. In the open loop, you are using the pressure of the pipeline. And also the closed loop has a disadvantage as far as the cost, because of the you are getting the you have to increase the pressure all the time, and there is a price difference of 40% on the closed loop versus the open loop. But both of them, and what we did also as Turkey, we have looked into all locations and we have examined where the best area will be for the open and the closed. And also, finally, we lay down all the advantages and the disadvantages, and within a short time, I think, a decision will be made. In the open one, there is no pump requirement. You are only feeding the gas from the main pipeline and using this gas and at that pressure. But in the closed one, you also have to increase the pressure, you have to put more electricity power, and you have to use more operating cost. So what is really so important about this? In Turkey, as far as the smart metering in domestic, we have not decided yet, but it will be coming in a short while. But right now, the smart metering is heavily used in the industrial process. So all for the industrial users, and it is also used for because being a hub, by BOTAŞ, which is the main transportation company of Turkey, and also by the gas companies for the line balancing. So with this high pressure calibration facility, somehow it will be linked to our SCADA system, and much better measurement we hope that we will achieve, so the efficiency will be much higher. Thank you very much.
Thank you very much. So, do we have any questions? Then I have a question. So, to summarize, in Turkey, a lot of the smart metering focus is on the industrial side.
Yes.
Okay. Now, do you think carefully about choosing smart meters or having standards around smart meters that can actually cover many different types of industries? Or do you think it's very one type of smart meter for gas, one thing somewhere else? I'm thinking it's all SCADA. A lot of these systems have SCADA. So can it be a SCADA-related smart meter? Can you do any?
There must be a, there will be a standard type for Turkish. I mean, definitely a standard. And we are now analyzing all the models because many European countries are ahead of us in the gas, like France, also Holland and England, Italy. So we are looking what we have in common with these people and what the experiences they are having. Definitely, one thing we have to do, of course, the smart meter for the domestic level has to be justified. For the justification, the laws in Turkey are about to change because still the transportation and the gas importation heavily is done by the government, so it will be much more liberal for the investment. And same time, as far as the ministry, we formed a group of making a standard meter for Turkey, for the Turkish needs.
Very good, very interesting. Okay. Any other questions? Okay, thank you very much. So, Livia, could you please? You can introduce yourselves. Very welcome.
Thank you, Henrik. Good morning. I guess you have, let me see, opening my presentation first.
Just push there. Boom.
Nice. Double touch. Thank you. Good morning, everyone. I said I represent Home Grid Forum, an industry alliance made of silicon vendors, so technology providers, system integrators, service providers like telcos and cable operators, all unified in an effort of having a home grid enabled for broadband connectivity of users. And Henrik, just because we need to make the panel very interactive, and this is the last day of the show, everybody's tired, had long days, I think we are going to make it a little bit disruptive. So I need your jumping mic. Yes, I'm ready. Thank you, sir. I'm going to have a question for you all. How many of you think you have a smartphone? Raise your hands. Should be everybody. Smartphone. How many of you think you live in a smart home? Nobody. How many of you, and that's the key point here, you think you can be a smart user of your all connected devices, be it smartphone, being smart home, being smart building, smart car? Yes? Yes, pretty much so, because we like connectivity, we like to live in a smart lifestyle and so on. So that's the whole purpose of the connectivity. GHN is a technology that stands for Gigabit Home Networking, introduces a concept like the highest bandwidth ever possible, And when you say gigabit, can be multi-gigabit, 1 gigabit, 2 gigabits, that enable high connectivity for us. Why do we need so much bandwidth? Because we want to have everything connected in the same time. Smartphones, smart tablets, smart TV, smart car, smart meters, which is the purpose of what we are here today. Smart use of our consumption, being, electricity, gas, everything we are using, internet bandwidth at home. There is this exponential growth demand. And the buildings where our homes are, where we live in, must be connected, first of all. And this is where the distribution service operators and telcos, service providers are coming into the picture. How can we use that, like a basic question, how can we use that network connected? How can we have what's behind it to enable the connectivity? So we look at what's already existing in this infrastructure. So we have power sockets available in every room, which is why the electricity companies can use these power sockets for enabling connectivity, the so-called power line connectivity. We also have so many phone lines available, and we have coax cables. In some countries, coax cables, it's really what drives the force. The industry challenges ahead of us. So we have this massive adoption of services, but we need to look at it from the user standpoint. That's why I asked you the question, if you can believe you can be a smart user of all these connected devices. Because historically we have been used to, and I'm coming from a telcos operator side of the world, we have been historically used to provide some lovely services, high bandwidth, smart use of all these devices, but we have not been thinking in terms of user viewpoint. As a user, you and all of us should have our own requirements, what should be out there. So that enables us to have a smart usage, like timely based, like in France, you have different hours-based power consumption, which is something the whole Europe should learn from. And then how can we connect all these devices to make use of that in a smart way? So looking at the broadband access connectivities, you have these smart buildings that get connectivity somehow, satellite communication, fiber to the building, and then inside the building needs to be further extended to every single user home. And if it's a residential area, same, to every single house. That needs to be done and can be done, and it's being done in a very straightforward way using the existing infrastructure, the power sockets, the electricity lines, as we call them, the phone lines and coax. What do we gain with that as users? We get the highest bandwidth possible. So of course, this is all about high bandwidth, multi-gigabit connectivity, as we call it, virtual gigabit Ethernet. Without us thinking of what's in there as a technology, we get that connectivity. Let's make it straightforward. GHN is an international standard of ITU, Standard Organization. It has been evolved over a number of years already since 2009, and it has been historically used, as I said, for telcos, for providing these connectivities, broadband connectivity on DSL gateways that we have at our home, internet connectivity, or so many hundreds of TV channels enabled by the gateway in the set-top box in our homes. Well, but how does that fit into the smart city? How does that fit into the smart metering concept? Because this is why we are here. We can use all these different lines for something else. And the power line one, I'm going to stick to the power line one because it's a straightforward one, very easy to understand. And because it goes us to highest bandwidth. So already today we have 2 gigabits per second that are in our buildings that we as a user do not think of, but the telcos, they know it's there. And this industry alliance has been founded by service providers to enable this connectivity for something else, as smart meters. Well, you have here the names of the founders. So it's purely telco and technology providers, but telco from all over Europe. This is, has been created in North America, and it has been extended to Europe and Asia. So it has the key service providers from all over the world that are looking into how can we use this in a smarter way to have the smart meters. It has already, so many deployment countries. So the infrastructure is already there in so many different countries. in the buildings itself, at the entrance of our homes. And then what needs to be done is the partnership between the telcos and the electricity or gas providers. And this is what it's all about. In Germany, it's being already used for something else, like the smart meters. Well, this is a typical example of a home. So you have this connectivity already there. We don't think of, but it's provided by the telco, the gateway, the broadband-enabled gateway. And then that gateway is able to connect any other devices as well, IoT devices. So we can have everything in users' homes, home appliances, Alexa microphones, like the ones Amazon we are playing with this morning. You can have the smartphones, the smart TVs, but also the smart meters able to be connected on that. So looking at the industrial applications, we see an amazing growth. This is why telcos are looking into that perspective. They have started with a home technology type of viewpoint. When they realized the technology is already there, we need to use it in a smart way and provide users with a different view of the technology, because the industrial growth is already here for us and provides different requirements. What can be done with this? So you see a number of applications, starting from the pure technology, computers, factory automation, cameras, and so on. One of purely techie examples of this technology in the industrial side has been to use in the smart buildings, on the smart elevators to start with, where you have Wi-Fi connectivity or Zigbee connectivity, wireless connectivity to call it this way, that we all like and appreciate because we can move around and, you know, like we are all here, we're still connected. But in the same time, in some particular places, we need a wired connectivity like the power line to provide us something else. So this technology has been using on controlling devices and voice and data and usage in smart elevators to start with. That's one. Another one is for street lighting in smart cities. The same electricity. So this is a pure example. I'm going to kill the mic at the end. Hopefully I have the jumping one with me. This is a pure example of smart city in Spain that is using this technology for providing not just street lighting, so you can drive your car and then or simply walk on the street, and when you get to the street lighting, you can also connect on the Wi-Fi access points that are powered by a wired technology as ITU one, GHN, and then you instantly have broadband connectivity like you would be in your office, like you would be in your home, like you would be in a hotel when you are traveling. So simply the same thing. And last but not least, but this needed to be a gradual understanding, so thank you for your patience, because I needed to drive you through all those details, getting you to the smart grid. So we have all these fancy different use cases, but what really concerns us is the smart usage where we pay, because at home we pay everything. When we are in hotel, we get free Wi-Fi. We are here, we get free Wi-Fi. Less or higher, slower or higher bandwidth, but we get this free of charge somehow, this connectivity. What really concerns us is smart users of the home. When we are at home, we need to pay everything. The water, the gas, the electricity, the internet bandwidth, the channels, everything. So the smart usage of all of that should be driven by us as a users. And now I put my user hat and get rid of my telco hat and think in those terms. Why do I need that? Well, because I pay everything for it. So then I can go and talk to the telcos and electricity distribution service providers and services, and then get them to understand me that I need to have a smart usage of these devices, a smart meters, or all IoT connected devices. And they are the only ones that can enable this connectivity for me as a user, because they have the network itself. So this is a pure installation that is being used in Germany by E.ON electricity provider. How can this be integrated in an open smart metering solution? Why do I call it open? Because we all like open platforms. We like to have technology that can be shared among all of us as providers. This is transparent for users now, but when you talk to telcos and distribution service providers, then they need to understand the open platform. So the home grids, it's the industry alliance between all these telcos, electricity providers, and technology providers that does a unified effort, again, for interoperability of all these devices, because it does a certification that requires, and it's transparent now again for the user, that makes sure that all these different devices can be connected. And even using your mobile phone when you are outside of home, you can still check the consumption of your smart meter, which would be nice. And you can see whether that's you are traveling, maybe the whole family is traveling, nobody's at home. Your smart meter should not go into consumption mode, or not heavy consumption mode, should be in a low consumption mode. And then you can see that and remotely control that when you are traveling, and on and off devices and so on. So this is something so smart to have, and it's being powered by this technology because it's wired and wireless in the same time. And with this, I'm going to finish because this is going into too many technical details, but I leave it for you to take it home. All these different protocols, and the one close to my heart is IPv6, as I have been involved in the creation of the IPv6 forum so many years ago, I don't want to count. It's something that we are looking forward to for enabling this so big network of connectivity, and on the smart user side, something we're all looking for becoming smart users of what we have already. Thank you.
Thank you very much. So, do we have any questions? You have to throw it. Do we have any questions? I have a question for you. Being from the telco space and being, in a way, working with connectivity and access and yeah, as a core business.
Yes.
Now experiencing the energy space, smart metering. Do you have any reflections? What you see is very different, or something that you have succeeded with in the telco space that you think is critical, that also the energy space and IoT and energy cracks? Or do we have challenges that we haven't thought about that maybe the telcos have done for years?
Yes.
Do you have any tips for us to think about that we forgot?
Yes, one of the key challenges that I like to mention because of my background as well is the standardization. It's something we do not tend to think about. It's something, it's just there. It's something, it's like the air we have to breathe in the morning. Without that, if it's going to be, I'm in China like every 2 weeks, and I can tell you the air is so polluted in China. And we still love to go to China, and we love to visit, everything in China. It's such an amazing culture, a country close to my heart. But you go out there and you realize, like we have here the air conditioning devices, you have air pollution removal devices connected everywhere, because this is something that is needed. Well, everything we have in every different country, it can only be connected and can only be deployed and can only be used if they are all interoperable. And so that when a network deployer selects and picks and chooses devices from different manufacturers, like we are all here, different manufacturers, they can mix them in the same network. They can only do that if they are interoperable. How they are interoperable? Because they are implementing a standardized solution. Standardization is so important, but we do not think of in these terms. It's something that telcos and electric utilities are realizing, I think. But it's such a heavy core business, and it takes time, standardization. But it's a challenge we should think of ahead of time, ahead of deployment. And I have a second one, if I can mention quickly, which is something that is closer to the user's heart, and that is security. And it has been mentioned by some of the panelists, and I think we're going to address that in detail. Since all this connectivity on everything you can think of, from smartphones to the smart meters, we are all transporting data. Which data? The government data, our own data, users' data, how much we consume at home, what have we been really using, how many channels, how many gigabit upload, download, how much we have been using the washing machine and the fridge. And all these different things are data consumption that we might not be so concerned, but I'm sure some of us are. And this, I'm not talking about GDPR, I'm talking about exchange of data, private data. So the security of all these devices, but it's something, again, that it's out in the background. The way the security is being handled with the protocols and so on, it's something, another challenge to be considered.
No, so I was hoping you're going to say standards, and you did it. Thank you. Now, I want to explore that.
Yes.
How did that come about? This, you're breathing this like air in telco, and here it hasn't really settled as it needs to be really strong. How do you go about working with standards? How does that work in the telco industry? And what can we learn from that and bring, what sort of consortium, forums, what do we need in energy that we already have in telco?
Right. And it's a very interesting question, Henrik. And I could talk about that like the whole morning. Telcos, historically again, they have been participating in what we call as SDOs, not DSOs, SDOs, Standard Development Organizations, like ITU-T, it's the international one, and then you have ETSI for Europe, should be all known by many of you. And then you have one for China, one for North America, and so on. One for each continent. Telcos have been historically participating in these SDOs, and how do they participate? They provide their own thinking, strategy, and requirements in terms of platforms. Then system vendors, like all the system vendors present here, they also participate to a great extent, and they share their development of the product, the specification of the product. How do they imagine a specific product, being smart meter, being smartphone, you name it, technology-related device. And when these standard development organizations, what they do, they mix, they match the requirements from system manufacturers, device manufacturers, and from telcos all the time, and make sure that creates a unique way, a specified way that gets a blessing of the standard development organization as being a standard. And everyone should be bound for following that. It takes years, but we have that time. In a way, we never have time, but we have that time on the utility side, because utility side, and this is something I'm going to explain, the product, and you all know much more than me, the product life cycle, the smart meters life cycle is different. Once you install one, you're not going to replace it next month. That stays, or not even next year. On the telco side, this is something that quickly changes. Like every year, they can change the TVs, the gateways that install for connectivity in users' homes, the set-top boxes, they change that quite often. They provide new versions. Paying or not paying, or subsidizing, but they change that. Like once a year, they tend to do that. Even us, our smartphones, we tend to, at least some of us, or work phones, we tend to change and upgrade them. So the telco side have a life cycle which is faster, but the utility side have a slower one. And so they need to certify a lot and validate a smart meter, think in terms of like future-proof. And once it's installed, it's more difficult to be changed. So in a way, we have that time from the DSO's side. We have that time to think of this ahead of us and standardization and implement a solution that is aligned with some other providers in a way that can then stay there, I don't know, 2 years, 5 years, depending on, or 10 years, depending on everyone's planning and strategy. But participation needs to be ensured in these standard development organizations, in fora and consortia. Sometimes, and this is why Home Grid Forum, it's part of this. Sometimes fora and IPv6 forum and all these fora, they are faster than organizations, standard organizations, and this is something that speaks for their advantage, because SDOs are, heavy load work. So fora are important on specific subjects. You have fora on everything, again, on IPv6, on smart meters, on smart platforms, on everything you can think of. So if you can be part of SDOs, it's very important. If not, you can be part of fora, but make sure you align from the electric utility side. Again, this is from the corporate side, not from the users, of course. But the alignment, it is very important, so that all these requirements are integrated ahead of time.
I think this is so critical, and we should stop here, but I have to ask one more question, because I want to know myself. This is the crazy stuff. What's the standard for us in electricity that we should participate in? Do they exist in the same way as in telco, or are we missing it?
We are missing it.
Okay.
we are missing it. That's why the alignment should be done, and this is an effort by the Home Grid Forum from the telco side, because it's driven by the ITUT, by the standardization that gave this, and it was initially with the participation of the European Commission, to have is like a vision, like you telcos out there that Deutsche Telekom, A1, Telekom Austria, Telefonica, BT, Liberty Global, Ziggo in Netherlands, all these different operators that are part of the, and of course AT&T, Verizon, China Telecom, all these operators that have been part of the standardization, and they did the heavy lifting and they know what was all about. So ITU tells them, you go now and explain how is it working to utilities and make a partnership. And this is all about partnerships. There's some of them being done in Germany as we speak. They have been announced last week. So this is it's an ongoing effort, but must be a partnership between telcos and electric utilities or gas utilities.
Perfect. We stop there. Thank you very much.
Thank you, Henry.
We take our next speaker, Joachim.
Great. Good morning. I think I come here with a topic which is a little bit different. So my name is Joaquim Viegas. I come from Portugal. I'm a mechanical engineer pursuing a PhD in advanced analytics, and I'm part of the company Power Data, and I'm coming to you to talk a little bit about combating electricity fraud with artificial intelligence. So, Power Data. We're a small Portuguese company based in Lisbon, and we are basically a bunch of very ambitious data scientists that believe that there is truly a lot of value that can be taken from data. And especially in the utility sector, with all the smart meters rollouts that have been going on in the last years for quite a bit, we think that there are many opportunities that are being underutilized. So, and especially also in this sector, the information is quite difficult to handle. There are many different kinds of data, temporal data, data that is coming from, for example, written inspections, and also the volume is very big. So we believe that using techniques of artificial intelligence, machine learning, big data, we can truly leverage this. So I know I've come here and I started to throw a bunch of buzzwords. There's a lot of hype on this area, and I think every software vendor is throwing these words around, but I believe that this is quite proven technology and science, and we are just standing on the shoulders of giants, and this is very mature. For example, neural networks, which is maybe the most used technique in machine learning, has started to be used for load forecasting in 1991. Also, an example that I find is very inspiring in terms of managing this technology is what a team in MIT did in the New York City power grid, which is a grid with many different assets from different eras, many of them in manholes. And this team was able to, in a way, integrate all the data from the grid and do things like prediction of transformer failures and features with great certainty. So, as I think, the big need is to find a use case that can bring really great benefits to utilities. And related to this, our mission has been to combat electricity fraud and make the electricity grid safe, making sure that utilities can offer the best service to legitimate consumers and that they can reap all benefits from investments in infrastructure. So, electricity fraud is a topic that is not that much talked about and is in many cases quite sensible. And I think sometimes there's a misconception that this is only mostly a problem in developing economies, where sometimes fraud is more than 10% of total consumption. But even in developed countries, such as the UK, where it has been estimated to be over 150 million pounds, or the US that estimates put it at $6 billion. These are really big, have a really big impact to utilities. Additionally, there's been the wide rollouts of smart meters that in a way have helped reduce these issues, but also have a bit widened also the attack surface that is possible to do in terms of electricity fraud. There has been cases of false data injection and also hacking of the firmware of meters used in order to manipulate consumption data sent to the utility in order to reduce the consumption that is seen by them. So looking at this, we find that what we want to do is help utilities increase their revenue and also reduce the technical problems that come from meters being manipulated, and then can bring problems to the infrastructure and also create problems even to the communities with the fires and things like that. So in terms of fraud detection, there are normally three more traditional approaches that are used. One of them is based on hardware. So normally now smart meters have sensors that detect when the doors are open and some types of tampering events. Also they have much greater accuracy in terms of detecting, for example, a difference in terms of the current in different phases that can indicate that there is some kind of bypass. But of course, this can always be hacked, and it's always a much bigger investment to have to install hardware. Also, most of the solutions that work in this space, revenue protection solutions, normally have some kind of rule-based systems. For example, if the consumption for some months is under something, it gives an alert, and that consumption endpoint or smart meter will be inspected. Additionally, also there's the even more traditionally time series statistics, which are, for example, if the consumption of the consumer is under its mean and some standard deviation of some measures, okay, this gives an alert and this consumer should be inspected. Asset Power Data, we have been developing a solution, and we think there is a fourth and very important type of solution that uses artificial intelligence and just leverages the data that utilities already have and reduce the need for investments. So our solution, we call it Smart Fraud Solution, and what it does is take data from smart meters, the consumption data they are collecting, puts that together with some information on the contracts, and we just give it will just give scores on the probability of a consumption endpoint being the source of fraud or any kind of anomaly that affects the consumption that is being communicated by the smart meter. So this is a data-driven approach, and it has the benefit that it works a little bit like a machine learning as a service, so the integration is very easy. Regarding this solution, its implementation is very fast. For example, if a utility has smart meters, they can just join us, and in something like 3 months, we are able to show and test what is the performance of our model in their data. So the kind of features that we are working with is what I talked about. So we are mining smart metering data for evidence of fraud. We give a ranking to consumption endpoints indicating the degree to the probability they're having some problems or they're being hacked. We can find meters that are being sources of false data injection, and also some more sophisticated kinds of fraud. So the benefits to utility is the reduced overall non-technical losses, of course, keeping the meter safe, and also the reducing costs with inspection activities, which will be much more efficient. So again, this is our main message, that we want to help utilities increase revenue, and we are looking for utilities to work with us. Just come join us in a pilot, test us, give them, let's sign an NDA, give us something like 10,000 meters, some examples of fraud, and we can in 3 months, for example, give you what is the expected performance we could achieve with your kind of data and your kind of problem. So thank you, and these are our contacts.
Thank you very much. So, do we have any questions? Question? Yes? Are you ready?
Our method is based on artificial intelligence, so it's not really a statistical method, but we are just using a machine algorithm. Basically, we have a machine algorithm pipeline, so we take the data, we get some features which are, I consider, our main intellectual property, so the variables that can really translate these normally very small difference that can indicate that there is fraud or any kind of problem. And then we use a machine learning algorithm like artificial neural networks. What we use is not artificial neural networks, but I don't understand it. Model training. Well, the biggest, or normally our biggest time is not even on model training, it's more on data manipulation and creating the variables, the features that the model will learn. But normally our whole pipeline in terms of training takes around 24 hours. Yeah. Of course, the model does not need to be constantly retrained. To run the model, it's seconds, basically, to make predictions.
Any other questions? No, then I have a question. If you remember how I started off the introduction, we highlighted 3 questions that we all need to think about: the business models and roles we will take, how to deal with innovation in the smart meter space, and then ultimately how we now need to scope and frame what smart metering solution is all about. So my question to you now is actually pinning down topic 2 and 3.
Okay.
So if you now take a step back,
yeah.
You have a very concrete use case in smart metering.
Mm-hmm.
So here is an example of AI innovation that now is coming into smart metering space. Could you elaborate, think off your head as this bright consultant, how many more use cases that are data-driven like this, that is more for advanced mathematics rather than traditional approaches that you could see how we could benefit?
Of course,
there are so many, I think, but I would like to hear you
I
elaborate.
can speak to you a bit about my work that I've been doing in my PhD, basically. So this is one of the use cases I've worked for, but I'm in the MIT Portugal program in Sustainable Energy Systems, and my thesis is really this, is data analysis solutions for smart grids. That's basically the title. So one of the areas that I think has the most potential is in terms of also analysis of consumer behavior. So in a way, stratifying for utility, more not like a DSO that we are pointing more here, but for example, for utilities that are in sale, with artificial intelligence, they can have the power to really understand what their consumers are doing, and also understanding what is working for them. So if you have some kind of, for example, marketing going that worked, or you had some kind of offer that worked, or something like that, you can really understand what are the variables that are driving this acceptance by consumers. So additionally, another topic that I've worked a little, but I think there are already some very interesting solutions in this, is more on the operational side, and this is a lot of the predictive asset maintenance zone, where it's starting to get very good results in terms of predicting what is the expected, for example, failure rate or time to failure of some asset in the grid, in terms of, for example, transformers, feeders, and things like that.
All right, so you have very clearly, we have the fraud topic that was your example, and now you have go nuts on the customer side, and then you say go nuts on more efficient operations.
Yeah.
You can do it everywhere.
Yeah, I think so.
Okay.
I
Now-
think there's still a lot of challenges related to putting the data to work, because normally it seems that all these opportunities are there for the taking, but when you arrive to the utilities, you look at the data and you find a lot of problems. So you find different data sources that are saying completely different things. And you find here it says that this transformer is disconnected, and here it has a load. What is happening? And then normally this is the most difficult thing. It's data cleaning, it's data transformation, and it's putting the right things there, because then it's just some smarter work in terms of the algorithms, but that's not what takes the most time.
All right, so now we're talking about my third question. How do you frame a smart metering project or smart metering solution, right? So because what you're talking about now is that, first of all, we have the smart meters and we have the access and connectivity and all this, but in order to start doing this smart, start actually activating the smart part, you need to have your pipeline. You need to have that whole process where you ultimately end up where you do the algorithms and then however you use it. So would you like to elaborate a little bit on that stack? What are we talking about here in some example terms? So taking the data up, very basic, but just to show what is now in scope.
Yeah, I think in terms of the application of artificial intelligence algorithms, they do not need to have that big of presence in the utility systems. I think in terms of looking at the smart metering project, what needs to be taken into account is maybe have the foresight to think what are the data requirements for these types of algorithms, more than thinking really about what is the infrastructure in terms of technology. I think it's more thinking about data quality and thinking about really carefully about what sensors do you want to put and not put, because in some years maybe something that you do not have invested in could bring really huge benefits.
Okay, so if I understand you right now, you're highlighting, as long as we're on the IoT side, on the smart meter side, this is all about collecting data.
Yeah.
Right. So then after the collection of data, you have this whole data management topic. You need to clean it, you need to normalize it, you need to model it.
Yes.
Then after that, you need to take it wherever you want to do your algorithms.
Yes.
Yeah. Those parts here has not so much maybe to do with the meters, but it's your data platform strategies that you have next to it.
Yeah.
Okay, so this, how do we scope a smart metering project? One topic is the fundamentals, how we collect data. What sensors do we need to have to there? And you can stop the project here, but you need to be super smart so it's future-proof, right? So it's future-proof. Then you have, when you want to reap this smart part, you're most likely moving to other parts of infrastructure or into your data platform or cloud or whatever.
Yeah.
But I think to see that whole information value chain to receive AI is very important. Otherwise, it's not going to happen.
Okay. Exactly. Sure.
Good.
Thank you.
Thank you very much. So, Julia, please.
Okay, good morning everybody again. So I'm working for the French gas DSO GRDF, and I will a bit open the discussion this morning talking about the smart gas grid concept and explaining how it fits with the region's need to achieve the energy transition. So I will move a bit up compared to the smart metering concept and just explaining how it deals with the overall smart gas grid concept. So, as you may know, the gas networks are solutions supporting the energy transition in local territories, and I will list a few of them. The first one are anaerobic digestion and methanation solutions that helps developing circular economy in different territories because we use waste from agricultural sector, industrial sector, or local authorities to make green gases. And it's really based on local territories' resources. And these gases are injected into the network. Then we connect low carbon and low emissions mobility station thanks to compressed natural gas stations. We are also a partner of energy efficiency solution, and we eased and improved energy management. And here we have the famous smart metering architecture and data management. We also help territories to optimize the consumer's bill as we're able to integrate smart products offering flexibility for the power grid with hybrid boilers or micro CHPs. And I will explain a little bit afterwards how it works. The objective here is to have the gas network as a partner of the power network to limit power reinforcement using the flexibility of the gas grid and having bridges between the two networks. And it helps through power-to-gas application, for example, also to improve greenhouse gases emission reduction as we have a way to maximize integration of renewables, especially power renewables, by transforming the electron into hydrogen and injecting the hydrogen into the gas grid to deal with seasonal changes in or non-balancing between offer and demand. And with the gas, we're able to store the energy from the summer to the winter. So that's a key partner of integration of renewables in a large sense. And the smart gas grid is the enabler of these new functionalities. What is smart gas grid? I'm sure all of you are aware of the smart grid concept for the power network, and the smart gas grid concept is a bit new. The beginning of this story is almost the same than the one for the electricity sector, talking about the distribution, as it started with the need to integrate decentralized energy. And to have local injection really changes the way we have to operate the network in terms of data and so on. And on the other hand, we have also another driver, which is energy management, energy savings. The objective we have to help consumers achieving energy savings, and it deals with the smart metering. What is smart gas grid? It's basically new equipment on the network. We have to find low-cost technologies that helps measuring decentralized key parameters, the flow, the pressure, the calorific value, and we have to do it at the lowest cost. So we need help of nanotechnologies, low-cost sensors, smart meterings. We have to find also new ways of collecting data thanks to IoT, thanks to 169 megahertz solutions, which deal with GASPA infrastructure, our smart metering infrastructure. We have to find new ways of treating data. We see a lot of data coming from the network, from the smart meters, and we talk more and more about data analytics, artificial intelligence, blockchains, to find the better way, the cost-effective way to treat, analyze data, and to find the value of this data for us, for the customer, for all our stakeholders. And finally, smart gas grid deals with new ways of monitoring the network. I will just show you a movie explaining what is changing on our network and why we need to change the way we monitor the network. As you may know, gas network is much more flexible than the electricity grid because we do not have to ensure real-time balancing. But as we change the way we inject gases, as we change the way we manage the different gas qualities injected into our network, we have to change the way we monitor the network. We have to partner more and more with the transportation network in a different way than what we have done till now. And we move more and more towards local and distribution level balancing, which is really new for us. So I will show you the movie, which is always better than talking about all the solutions, and then coming back to some of the demonstration we perform to do so.
The gas transmission network is the backbone of the gas infrastructure. Transmission system operators manage the daily balancing. To meet this need, their network has been smart for a long time and is managed by dispatching centers. Traditionally, gas is transmitted from the transmission grid to the distribution grid. Biomethane has been started in France since 2011 with a decentralized production of green gas. This is shaking up the traditional model for network operation due to the emergence of local injection flows. For example, in some areas during summer, the quantity of biomethane produced may be higher than consumption by final clients. To address this issue and ensure that all the biomethane produced is injected, the network will become bidirectional thanks to reverse flow units. This is what the WestGrid Synergy project is aiming at. In the longer term, the gas network will offer a solution for the flexibility of the power system, which is more and more constrained by the development of intermittent renewable energies. The gas network will hence reinforce its major role in the global energy system. The quantity of intermittent renewable energies will increase in the power generation mix. As a consequence, there will be periods when supply will not match demand. On the contrary, gas infrastructure can offer interseasonal storage as well as considerable flexibility. Therefore, the question is how coupling networks can ensure a more cost-effective energy transition. Power to gas, by coupling gas and electricity networks, will provide an upstream solution for managing substantial interseasonal surplus generation of intermittent renewable energy. Electricity is transformed into hydrogen through an electrolysis process. This hydrogen can then be injected directly into the network, which is diluted with natural gas, or be transformed into methane using a methanation process. At the end, the produced hydrogen or methane can be injected into the network. Two major demonstration projects in France are focusing on these issues, GRID and Jupiter 1000. Network coupling solutions are also developed at local level with smart gas solutions such as micro cogeneration units, fuel cells and hybrid boilers, offering both very good energy efficiency and the ability to provide solutions to alleviate the local constraints of the power grid. The demonstrator Nice Smart Valley is giving these solutions a trial run. To facilitate these developments and offer more services to end consumers and local communities, the gas network is going more digital by acquiring more smart sensors and meters. The distribution system will also have a supervision center to manage operations in greater detail. Finally, the gas network is becoming more efficient. It is also producing data for its external stakeholders, such as local authorities and energy service players.
So that's smart gas grid in a few words. We are just at the beginning of identifying operational use cases of the smart gas grid, and to help us implement the cost-effective and the right solutions, we are doing demonstrators, of course. I will just talk about a few of them. I will present them now and dig into it just afterwards. The first demonstrator mentioned in the movie was WestGrid Synergy, and we develop a reverse flow solution between distribution and transportation networks to maximize integration of renewable gases. We move up the gas to a level of pressure which is more important, and in that sense, we cope with the balancing issue at the distribution level. In this project, of course, we have to think about the data we have to collect from the network to do so. We have to deal with the issue of which kind of data do I have to exchange with the transportation network, what is the need in terms of do we need real-time, one-day data flows, do we need extra sensors on the networks to ensure that if we make reverse flow, we still have the right quality of delivery at the customer's home, and so on. Then we have the GRID project, which aims at testing injection of hydrogen into the distribution network up to 20% in volume in a mixture with natural gas. So here the question is, we have to qualify the impacts on the network and on end users, and also we have to check that the data flows between all the players is working well, between the electrolyzer, between the storage, between our injection station, and to ensure that at each time we control the percentage of hydrogen we have into the network, and to ensure that the meters they count properly, and so on. We have then NIS Smart Valley demonstrator, which is part of a European project called Interflex, which is really innovative. Is that it's the first time that we test smart gas products as partner of local power flexibility solutions. We will implement hybrid boilers, micro CHPs, and we will really monitor them, control them based on aggregators' demand to answer to power system needs. And that's really new. So we have to develop connectivity solutions between the gas products and the aggregators platform. And we have to see how these solutions are positioned within the portfolio of aggregators and which value they bring, and how it works in terms of data flows, once again, between the different stakeholders. And I should have started with those, in fact. We have experiments on energy management based on our smart meter, GASPA. We tested with the environmental agency in France, ADEME. We tested different approaches to determine really what is the most effective means of encouraging customers to use gas consumption data to control their energy consumption. We worked with several stakeholders, local authorities, landlords, consumers. We tried different approaches using social networks, energy box, and so on, trying to see what is the good way to give customers data, how they use it, how to help them understanding their consumption, and how to help them having the right solutions to reduce their energy consumption. Some additional words about the GRID project. So what is really important is that all of our demonstrators or experiments are always done in a close link with the local authorities, the regions. We really act with them as partners to ease social acceptance of smart gas grid solutions and to build them in relationship with the local territories and with consumers. So GRID is based near Dunkirk in France. The project started to inject in June 2018 with 6% of hydrogen in a mixture with natural gas. We will very soon move to 10%. And then next year, we try to achieve the 20% threshold. The end of experiment is scheduled for March 2020. And we do it in a very new distribution network. We address a limited number of customers, around 100 homes, one tertiary building, and we will verify during the whole experiment what happens on the network, what happens on our smart meters, what happens after the meter on end-user equipments, boilers, cooking appliances, and we'll use the results of this demonstrator to define rules for injection of hydrogen into our network, talking with the transportation network operators, talking with the storage operators, because as you've seen in the movie, as the network will become bidirectional, we have to ensure that what we choose for our distribution network is consistent, what is acceptable on the other side of the infrastructure. Talking about Nice Smart Valley, I introduced this demonstrator explaining that it is really innovative if we look at the gas aspect. So this is a European project involving 6 partners in France. The leader of the project at European level and French level is Enedis, the French power DSO, one of the French power DSO. And the project aims at testing cooperation, one of the aspects of the project, because I would say the main goal is to test different ways of delivering flexibility at local level for the power grid. But really we try to test the sector coupling, the collaboration between gas and electricity grid through flexibility services. And thinking about data, this is a real challenge. What are the data formats consistent to integrate gas parameters into aggregators platform? What kind of data do we have to exchange? And we think about the future. Do we need as a DSO to receive data from flexibility to be able, if it becomes wider, to receive information about flexibility impacts on our network? If for different reasons we have to deliver massive gas volumes to address flexibility power needs, we have to predict things and we have to adapt our network management. If we talk about smart metering, so I told you we've done many experiments with the ADEME agency. What is interesting is about the results. I forgot to tell you that in France, the reason why we implemented the smart meter for gas, they were 3. The first one is to improve the customer satisfaction regarding billing, to have accurate billing, monthly billing based on real data. The second one is really energy saving, helping customers achieving energy savings, and in the business case we have 1.5% of energy savings, and we account for this to the regulator. And the last one is, of course, improving our own performance and the way we monitor the network. The results of the experiments, the objective really was to see how customers they use the data and how to help them improving the way they use it. So first one is we confirm the potential for energy management linked to smart metering. We expected 1.5 and the results were around 5%. So it's a good thing. Second one, we consider that the entire stakeholder system must take on the challenge and reassure end consumers. As you may know, smart metering and other data management aspects, we have to deal with social acceptance, and we have to ensure that customers, they want to use data, and they want us also to value this data for a different purpose, energy savings, but also for us. It's a key thing. And finally, we have to adapt long-term communications on such objects and always ensure that what we want to do or what we expect as a value from the smart meter is well known by the consumers and other stakeholders. We are not alone, and we cannot achieve energy savings alone with the smart meters. Really, we need really the community of all stakeholders, once again landlords, local authorities, service providers and so on to achieve it, and that's a key and tricky thing. As a DSO, regarding the smart meters data, we have different kind of solutions to deliver energy consumption data. And indeed also with the question, what kind of data do we have to deliver? Where do we stop? So we have currently open data at aggregated at a national level, consumption and injection, because we have biomethane in France, aggregated data on demand for special and authorized stakeholders like local authorities or building managers. And we have also individual consumption data. Basically, we offer free access to a portal to the end consumer, to the energy consumption. And in order to deal with all the smart meters data coming from different operators, we decided with the other DSOs, and especially the Power DSO in France, to build a common platform called ORE, to have only one entry point for authorized stakeholders to get the information about consumption, gas, and electricity. That's the beginning. Maybe we will open it to other utilities, but at that stage it's gas and electricity. And that's one of our answers, as the rollout of smart meters are already started in gas and electricity. But that's one of the many questions we ask themselves regarding data, which kind of data, and also what's the cost of this data, what are the data our stakeholders need, but also what is the cost and what is the most cost-effective solution and the most efficient solution of treating and giving data to these stakeholders. And that's one of the aspects of smart gas grid I wanted to highlight. Thank you for your attention.
Thank you very much. Thank you very much. So I'll start with some questions on the floor. Do we have any questions? Any questions? No? Then I have a question. So I'm trying to understand this now as a consumer. I have my consumer hat on. So in my house now, and I have a boiler, so I can have gas this way. Do I have 1 meter for electricity and 1 meter for gas, or are we talking about that we should have 1 meter that can manage everything?
Currently in France, you have both. You have
both.
1 smart meter for electricity and 1 smart meter for gas.
So this is 2 different meters?
Yeah.
Okay. But ultimately, if I want to have efficiency in my home, I want to steer it as a system. I want to have my convenience of how my heat is going compared to if I'm there, or, yeah. Do you think it's going to be 1 meter or always 2 meters?
Coming back to one of the questions before, I think the meter can be different. The question is, if I am a consumer, in fact, I don't care to have 2 meters, if I can read all my data consumption information on one portal or something else. I think that's the question. So today, basically, all the operators, because this is the regulation, they have developed their own platform. So if I want to see my power consumption, I have to go on my power portal, or if I want to see my electricity consumption, my gas consumption, I have to go to another portal. But it's possible that a service provider, basically an energy provider, he receives my data and it offers me an integrated vision of my energy consumption. That's the way it has been built in France. So you can decide to give your data to your energy provider or another service provider, and then he will offer you the service to have everything put together. And that's not the role of the DSO, and I think it doesn't care if you have 2 meters. If I am a consumer, I just want to have an easy access to aggregated data.
Yeah. So I can imagine from that person, but to double up 2 rollout projects, if I don't need to do it, that would be nicer to roll it out once every 10 years.
I would say too late in France at that stage.
Too late in France. In other countries, think about this. Think about that. Okay, any other questions? Very good. Then we will come to the panel discussion. So I would like to have all the speakers that has been presenting up on stage. We can sort out the tape this, and we'll start the panel discussion. I think better to bring that in a little bit so we can see closer. And then actually, of course, I got the question from the panel. We want a picture of the panel. Yeah, please join. Now, so we'll start by, while he's taking a picture, the way I would like to start this panel now. We have heard different perspectives on this, and I find it very, very interesting that we've had both the core smart meter dimension, electricity, we have had the AI dimension on this, and we've had gas or even industrial smart meter dimension in here with what Kem also presented. So we have a little bit different perspectives here. So what I would like to ask the panel to start with, for each of the presenters, just highlight what you think is, from your perspective, one of the key questions that you are thinking about, that you really want to share, that when you work on this topic or when you work on this is a question that you need to have in mind when you're building or when you're developing. So, because then we can have a little bit different perspectives on this. So Andre, you could start.
Okay, sure. From the perspective of DSO company, like Tauron Distribution, the most important question is what would be the business model for the smart metering rollout in the future? What should be the role of the DSO? Of course, we have to think and to have the customer perspective first. But anyway, I saw a very interesting presentation during the first day. It was titled Considering DSO Company as a Smartphone. And it was very open-minded that DSO should be the enabler of all this transformation, but we have to define very clearly where to stop. Yeah, do we treat DSO as like the company that delivers metering data, and there's everything that is behind the meter is the other players' activities, like sales, like IoT suppliers, telecoms, so on. Or how to deal with this, how to develop the cooperation to make this platform, the DSO platform, be open for all these technologies. And this is the point, and this is very crucial from Poland perspective, that it's good to have a clear vision from the very start. Yeah, we are before the massive rollout of smart metering, and it's good to find a solution right now.
The business model question, back to one of the core questions I open up in the introduction. Any comments, any reflections? I want to introduce Mario as well. So he's joining the panel here, so you can introduce yourself. And
so, I'm Mario Dionisio from the European Commission and from DG Energy. I was not among the presenters, but I'm participating to the panel. So I want to give confirm what I was saying. We were saying previously. So the first thing regarding the use, the need of a smart meter, which is not at the end is not only a smart meter that we need, but everything is around. It's the smart grid. The first thing is a business case. I mean, if I'm aiming at something, I must first see what I need it for. based on that, I think technology has many resources to provide all the possible solutions to aim to that scope. So the European Commission has dealt with the smart grid, the smart meters solutions, the smart meter proposal for the rollout, and there's a certain status that I maybe refer afterwards.
So we come back to thinking, to listening a little bit more about where the Commission is on their work. I think we really want to hear that also. Any other reflections on this business model topic? I think this is core, but we have so many different use cases here, or we are coming from different roles. So how do we talk about this? How do we?
I think it depends from the goals you have at the beginning when you decide to make a smart meter rollout. Talking about France, for example, and gas, we really have as the basis of our business model customer satisfaction, so billing optimization and energy savings. And so we decided to have a cheap smart meter to fit with these goals, and so it really depends on your goals. And for me, talking about the business models and also the limits of the DSO, we have two questions. We have to how to ensure that finally the data we provide, they are used to achieve the savings which are part of our business model, and also how can we value the data also for our own needs without increasing the cost, really in a cost-effective way. And one of the key questions for us today is how to use new or disruptive technologies like artificial intelligence and other new solutions to use the data for our own needs in the most cost-effective way to ensure we are in line with the business model, and also to ensure the lower impact on the tariff, because at the end all the costs, they will be reflected in the tariff and on the end consumer. So that's the key point for the DSO.
Any comment? Yes.
Thank you, Henrik. To complement what Julie said, and from the perspective of the partnerships, global partnerships that we all want to reinforce here. So again, it is not a matter of who should be doing what. It's a unified effort among all the stakeholders. The distribution service operators, the telcos, the system integrators, system manufacturers, everything. And the inflection point, so the intersection of the success keys, relies on all the time what users needs and what technology altogether can provide. Because the technology is out there, it is already. It has all the ingredients. All of these fancy different devices. You may have heard now the smart fridges enabled by Powerline again, that when you are getting out, shortage of some food and you think of recipes, and when the fridge will tell you, you only have 3 eggs, 1 bottle of milk, and a little bit of bread, you cannot do much cooking about that. So you need to refurbish. So isn't it something amazing nowadays? So same thing, the smart meters will be able shortly, smart grid as a whole, will be able shortly in only a few years, I think, to tell you, you have been using too much, power consumption this month. You are going beyond your limit, or you still have so much to use, and you can use that in a smarter way, cost-wise, times-based wise. So that's so amazing. So the inflection point, it's always between what the users need as a platform to control in an artificial intelligence way-based in all sorts of means, and it can even be voice activated, like talking to your own smart grid. That open platform that enables that, it's the key for success for the business models, because otherwise we have so many different vertical markets on the smart grids, on the smart appliances, on the smart connectivity inside the home, outside the home, as from the access last mile that somebody mentioned on the panel. So many different vertical markets. Then the IoT hype. IoT, it's still a hype for now on, because it needs the standardization, and I came back to that. So the ingredients are all there, need to be cooked in a smart way to have this interaction. It's all about the dialogue. Like we are all here today, we understand each other because we communicate and you listen carefully and peacefully and with your patience that we appreciate. So this is how we enable this dialogue. It's going to be the same between users and all these different appliances like the smart grid.
So coming back to the already topics discussed, maybe a slightly different view. Where do you stop, implement when it's your solution or your enabler for different other products? I think it really comes down to what actually users want and what are they ready to pay for that. So you can have all the technology that you want. You can play with all the technologies, pilot everything, use everything. It comes down to who's going to use that, and this is also true for internal processes in the DSOs and all the other companies, but also the customers and clients. So always we need to keep in mind what is the business model for us, but what is actually the use case and also the business model for each household, for each user, how much they need this and how much they're willing to sacrifice for that. So that's also something to keep in mind.
I fully agree with you and with the rest of you. Yes, that's true that we have technology, we have hardware, and we can prepare any kind of solution. And I want to point one of, I think, crucial thing in the business model and the functionality of what we are doing, because the awareness of what we can achieve through our solutions, we know them. But if we're talking about the end users, do they have the awareness what they can get from that information? So everyone who is on this event know, okay, what we can do, what we can provide, and how much efficiency we can achieve. But don't forget about the end users. Do they have awareness about what they can get? And if they will have awareness what they can get from smart meters, then it's gonna much more help us to provide better business models.
Excellent. So we are still standing on business models topic, but we're actually exploring it in a couple of different ways that I want to summarize as we are doing this panel to give you the first takeaway here. This is the first takeaway that I take when I listen to you guys. We need to listen to the customer. We need to be useful. We need to have someone who is willing to pay for something. Okay? So I feel that sometimes in a utility myself, that we go the other way around. That we are trying to think about how it's... I see a business case explained first from the Vattenfall point of view. That, of course, I need to have my business case, but it needs to start one, who's the customer's customer? Or who is the ultimate... So how do you monetize this, or who is willing to pay? This is the number one takeaway. Then we are circling back here that the main challenge we feel right now is standardization. So we have all the components in the room here, but we have not come as far to organize ourselves around this dialogue if I compare to the telco space that has clearly achieved this. So there's a fundamental component missing here to make that dialogue happen. It's something that needs to be like the catalyst. Someone needs to drive that or steer that. So I want to stay on that question. Who should initiate or who should be the coordinator in the utility space for this standardization or this dialogue? Who will take on that hat and make that hard job? Mario, what do you think?
Okay, thank you. Well, from the Commission side, the fact is that the Commission can enable, can support all the standardization institutions to come up with some standards, to push up, to look forward for some technologies of some smart device actually. And so it is not the Commission per se that does the standardization, but it can only facilitate.
So I think what we in the industry is looking for is great facilitation, because in the end, as you highlighted very clearly, It's the technologists, it's the super big vendors that is one side of the coin. They need to explain what they can do. And then this us, the operators who understands our customer, who might even have the data today, who could try to understand the business or use case side. But it seems like a facilitation of this group would be very nice if we could organize it.
But talking about standardization, I think we all have to implement open protocols or something like that. For example, in France, we have a plug that on our gas power meter, everyone can plug something to get the data from the meter if the customer is okay with that. But I think we have also to think about the reality. I think the issues are different depending on the countries. We have seen that we have different situations at the beginning. So maybe the response and even the technological response can be different. And also we see that the issues are a bit different in gas and in electricity. And we do not need the same technology. I come back to gas power. For example, we decided to make a cheap solution. For example, we cannot switch off remotely the consumer. Or we decided not to integrate at the very beginning other functionalities because we thought that they are not needed or required by the consumer or by our stakeholders. So I'm not sure the answer is to have just the answer is to have a standard. We have to standardize part of the solutions, to have cheaper devices and so on, to have protocols that can be used by all the stakeholders. But we always have to keep in mind the business model, the reality at the beginning, and to speak about also how to use the data. And maybe what we could do is to share our experience of data analytics, of how to use the data for value. There are many use cases already identified for electricity grid, for example, but for gas grid, we still need to work together and see how we can enhance value coming from those meters for different use cases, and each time ask us if it's relevant for us, for our customers, and if they're willing to pay for that.
I can also maybe add to that, and according to my experience, technology itself is nothing really, it's not a silver bullet, because technology itself, either it's the greatest technology in the world, usually if there is only one proprietary solution, that is a showstopper for most DSOs, because that is, you cannot be locked in with one supplier. That is a huge risk to take. Some still are doing that, but I think that the standardization is a good way out of that. So if you have great technology, you have a great standard, transparent and easy to implement and good standardization body that keeps evolving that. And then the keynote is there that this standard must be sufficiently flexible. Because, as you said, the business models are different and also use cases are different. Each customer in Europe is different, depending on country, depending on region. So different customers want different things, and this standard must be open enough to be able to facilitate all these business models and these use cases, but also must be closed enough to limit the variations so that still the technology interoperability is valid within the standard. So I think that is a very fine line between those two, interoperability and flexibility. So I think that is also very important to keep in mind in future.
And yeah, I think this whole work using standards, what does that mean? It's almost I can hear it when we are talking here. It means different things to us here. So I think that is the first thing when we're not experienced in this field, how you set standards that are open. So the standard is actually the facilitation of openness that things can work. So, and in relation to going open versus proprietary. So the problem is that we have proprietary approaches in the different verticals. And this proprietariness makes it, as you heard in these cases, when you want to do AI, when you want to do all this, AI is not the problem. it's the interoperability between our data sets that's the problem. It's the fundamental understanding how I link that part of the data with that part of the data. This is what, so it's actually to make sure that we have an interoperability that we want to do that is then flexible, but at the same time, as you said, flexible and excellent.
And sufficiently interoperable with different solutions.
It needs to be open, flexible, but also it needs to be rigid so we can clearly, have one protocol, like IP6. One protocol makes internet work. That's how, otherwise internet wouldn't work.
To complement on that shortly, because it's a learning curve. I have been living and breathing and eating for the last 12 years on the standardization side and under the guidance of European Commission that we had in Etienne ITU. Many telcos, so internet connectivity operators everywhere, Europe, US, and Asia, they have started their first deployments selecting things, devices, partners, device manufacturers, and services based on price, which makes sense, costs of the device, of the deployment, and so on, based on their return on investment strategy, which makes sense, of course, and on the ability to have the implementation, which is something very internal cooking. But they have never selected the best technology, and I'm talking about 12, 10, even 8, even 4 years ago, it happened, that they have never taken into account user needs. So they started to deploy, and I'm talking about these IPTV services, all these TV channels, but everybody has at home, internet connectivity at home, everybody has it. So once they deployed it and was a great choice of the partner in terms of device manufacturer and everything, cost effective for the user, and everybody was happy. And then they decided to mix different, or add new partners into the picture, into the deployment. New devices, so new device manufacturers, new services, and to ability. They suddenly realize they do not interoperate. So that's the key word that I really love. And this is how you translate standardization. Standardization is really such an abstract word. We know the importance of it, but it sounds so abstract, really, to so many of us. How you translate standardization is interoperability. The fact that you can, and I love when you said that, but you can mix all these different things, and they work with each other. Imagine you all have very nice headphones. Instead of getting them here, you go and buy them in your own devices, retail homes. You bring them fancy, pink, blue, silver, then you connect here in the room with us and you cannot hear what we are saying. Or even better, you hear, but it is not, it's like we wouldn't be in common English. Like it would sound in a different language. And it happens like in the ITU, NATO, you see all these different, congressmen that have the translators. Because that's interoperable. Otherwise, you'll have all very different, nice, fancy headphones, but we would not interoperate. Would not be this dialogue. So that's the key, interoperability. It is so important. And telcos, they went through that pain hurdle. They lost a lot of money, all of them, until they realized interoperability needs to be thought ahead of deployment. And it will come a point in time when utilities altogether will go through that again. But now they can learn the lesson, like looking, I like to say, there are 3 types of companies. Companies and also people that learn from other people's mistakes. Companies and people that learn from their own mistakes. I've done something wrong, when I learn, next time I do it right. And there are companies and people that never learn. So we are hoping none of us are in the 3rd category, and we can share, and this is why we are here. We are sharing this learning curve, all of us, these platforms of exchanging experience, and then I think everything will go on the right track.
All right, thank you. So I hope the message is clear. We spent a lot of time talking ultimately on business model, interoperability, standards, and how to achieve that facilitation. Now, I want to throw out, do we have another big question that someone is sitting on thinking about in the room? And I would like to start with you, Mario. Give us a little bit of a status update on your thinking and what questions is really on your daily agenda?
So, I can give an update on. It's just a question of. This is just a question of numbers, but anyways, less interesting than what we have been saying up to now. In any case, from a review of the Joint Research Center of the European Commission, the smart meter penetration in new consumers, well, based on member states' commitments, 70%, 72% on smart meters, electrical meters, and 40% gas. This is from the September 2018. And this corresponds to 200 million electrical smart meters and 45 million gas. For investment, total investment of 45 billion by 2020. This is based on each member state makes a cost-benefit analysis. For some of them, this cost-benefit analysis was positive, so they invested in this sense. Some others didn't yet start because from the less not so good the cost-benefit analysis. In any case, the process is ongoing. And we are looking also at the next steps. So the important thing, as it came out also from the discussion, is good information communication to customers and consumers. That's very important. And the other aspect is regulatory measures, just to speed up the uptake. And also we have to look at privacy and the security measures as well in this sense. And yeah, this is mainly the main aspects that can come out from this last review.
And I would wish that we put interoperability facilitation high up on your agenda, if you can help us with this. So.
Indeed, I did not mention, but it's true. We are looking also at interoperability and platforms. We're making the discussion clearly on platforms related to smart grids, and we're linking this to the development, the digitalization of the grid in general, and with calls that have been open and on IoT and smart homes. Some are still open calls and some are already closed. In any case, they are all aimed at making platforms accessible, easily accessible, interoperable, in such a way to promote, to make, give a push to the smart grid. Clearly, with this increasing amount of devices and smart meters, etc., and IoT, we have also a big amount of data that has to be managed. And so the big data, there has been also a big data call, which I think is still open until next year. And we have also dealt with, since we're talking about the smart grid, we are not thinking about the grid as we used to know. There's the need of communication between DSO, TSO, and consumers. So there has been a call also on this. And the last point, which is involving also smart grid, is the cybersecurity. Clearly, increasing the access points, we open the doors to more cyber threats. And so the electrical power system, which is a critical infrastructure, because all the system depending on the availability of electricity or power or not, has to be shielded. We have to build an armor all around the electrical system to make it resilient to cyber attacks. So these are the 4 points. And one other point I was forgetting is there's also the 5G. We are discussing about smart grid, but an important thing is the communication among all these devices. And with this increasing rate of amount of data, it is clear that we need a communication system more reliable and that allows this wide exchange of data.
Thank you very much for that insight to the Commission's work. So I want to leave now for questions to the panel from the floor. Do we have any questions from the floor to the panel? No questions from the floor?
In the meantime, I would just like to add something because we see that we are just at the very beginning of data analytics or finding solutions to treat and to give value to our data. So we need, I think, two things talking about network operators. We need to have the rights to make experiments, demonstrators, and here I'm talking about regulation, national regulation, European regulation. We need to have the ability to have a small proof of concept, taking the data, doing things with them, using new data analytics, experimenting things with partners like Power Data, with telco partners. We need to have experiments on that side. And so we need first regulation things, but we need also R&D funds to pursue the next level of smart metering or smart grid development. And I think this is a key, and it has to be open. So it exists already for electricity, but we talk about gas more and more because we have new issues to deal with, and we are talking about also about sector coupling. And we need to work on it. And talking about sector coupling, we have huge work on data transfer between both of us because we do not use the same standard. We have to communicate each other. We do not have the same the same pace when we operate our network and so on. So this is a huge thing we have to perform in the future, and we need the budget and the regulatory framework to do so.
I would like just add something to you because I fully agree with you that right now we're speaking about the big data and how much data we can deliver and provide. We can forget and miss the thing about the quality of the data. That if we want to try to squeeze something which is beneficial for everyone, we need a good quality of data. Right now we're gathering all this data, and we, as I heard on the whole presentation, right now we have two main ideas what to do with this data. One is to be more efficient, the customer pay much more, and try to maybe find illegal consumption of energy. This is the more points that we found. But in our project, for example, we're trying to find more benefits, and at the end of the road, we won't know where we will be because we have so much data, and we need to try to find so many ways how we can proceed them and what can we drag from them. So it's still an encouraged path for us, and this is RNGD project right now.
So now we're going, I think this is interesting. We have a business model discussion. We're realizing we need some strategic level standards. And now we're coming down to the fundamentals, the core fundamentals here, when we want to be smart in our smart meters and in our smart grids. So here now we come to what is, on this more operational level, what is the more core questions we want to think about then? I think the first one here has been said, data. How do we deal with data? How do we manage our data? How do we secure the right data quality? So I think that forget about the system for a little bit. Forget about the smart meter technology for a little bit. But now is the essence of managing data and being good at that. That is what I take out as one key question here. Do we have other, or does anyone want to expand on this, or any more of those more operational level core questions? So we are moving more operational now in our discussion for a little bit. Would you want to?
I was thinking about something, but it's not that operational because it's just connected what Mario was talking about the cost-benefit analysis that was done on smart metering. and also the business models that we were talking about. And I feel that the benefits of installing smart meters come from very different places, and we are focusing, it seems, most of the efforts in what is consumer engagement, trying to find how to help people be more efficient. But I feel always a little bit of an outsider on these questions because I'm working against electricity fraud and I'm trying to reduce non-technical losses. And I find this is also a business model, and this is something that could also be seen in the cost-benefit analysis on smart metering, which is one of the most impactful aspects. And I think many times it's expected that, okay, we installed smart meters and non-technical losses disappeared. And I think this is not reality, but it's only something that I wanted to point out.
Yeah, I also, it's very interesting. It really falls together with the first statement from colleagues here that it really is a question, where do you stop your operation? So it really is, you have a pile of data or you don't, right? So then you have to decide how much data you can use by your own, how much is cost effective or positively enhancing your company, and what can others do with this data. Of course, keeping in mind the data protection and also the risks of sharing large sets of data. But yeah, the same question applies. Who else can use this data? Who else can benefit from that? And if I cannot benefit, but I still have the data, then maybe that becomes also a business model, right? So there's always this this question. But the data quality, of course, that is a cornerstone to each and every use case, business case, everything. Data quality is so basic.
Still hard.
Yeah,
still
and
hard.
And it's very hard. Yes, it is.
Yeah. So I think this is interesting now because now moving into the operational side, we actually also unlock more value. So this value topic comes from understanding the customer, but then it's also made the understanding who could be a customer for the DSO. Who could be the customer in the future? We talk about a networked ecosystem. So maybe if you are now doing a cost-benefit analysis to do a smart meter rollout, how will you monetize that? And maybe that monetization is part customer, but part also being another type of data provider in this.
Yeah, and also that can be a community work also. That is not necessarily always a business case. Like now there is these digital data-driven countries even. There are a lot of countries in Europe are organizing these data lakes, which are non-protected data sets that a lot of companies can use. They're free of charge. So that is not a business case for a DSO or for the other company. But if anybody can use that data and gain benefit for any use case or their business case, I think that also helps community, helps the economic situation. So that not necessarily always that the data is driven by business case. It could also be any other community service.
Yeah, so I really like where this is going now. We are going away from talking about the technology to the usage, and the usage is completely related to data products. You know, in some ways, services that we can now do by more efficient analysis of understanding the customer, understanding the grid. So now we're entering into a data conference, guys. that is the truth. That is the truth. But sometimes it feels like we are not talking about the data itself enough. We are talking about the technology, or yeah. So that's the reflection. Anyone else want to comment on that, or?
I just want to say that that's true because right now, gas industry, energy industry, for example, water industry, if they and when they fill the market with the smart meters, they will have so much information about the whole society, about the country, and if they're willing to share this information, the whole economic, the society, can gain much more from this information, because how much we can gain from it is still open questions. But if we would like to share this information, how we're using water, how we're using electricity, how we're using gas, who knew what benefits it comes. So yeah, I fully agree with that, that this is something really important, not on the business level, but on the society level.
All right. So spinning now on this different business models and where we are now. So now we are more talking about the customer, consumer, as a prosumer. So let's leave we're not talking about the customer anymore. We are talking about the prosumer, EV charging, solar on the roof, and they want to participate in the energy ecosystem now. So for me, I saw some great presentations on the Tuesday, highlighting also that for DSO, if we think about the whole ecosystem and this, challenges in the grid, challenges to go from high voltage to low voltage, challenges with having massive amounts of EV being put into the grid, we actually want to incentivize our customers in the end maybe to use or to do their consumption that fits the grid. So actually we want to steer the customer for the optimization of the grid, so we don't need to build, so we can have a more efficient grid. So would you want to elaborate on what is that taking the smart meter story? Because now we're going two ways, and now we need to have contracts. Now we need to be able to participate. So where is this going? Anyone wants to elaborate?
So with the clean energy package, so the European Commission, the main actor, where it puts the consumer at the center of the energy system. So the consumer, as mentioned, he becomes a prosumer. He produces electricity. He can, let's say, adapt his consumption to the needs of the grid. So he puts the data he has in the house, a smart house, available to the other actors, so the net operators and the aggregators, etc. So in this way, we can enable more energy saving, energy efficiency, and also a more integration of renewable energy in the electrical energy system. And this is important for the decarbonization need. That's the main point we're aiming to.
So I think this storyline, so this is how it all connects even to the most strategic topic of how we decarbonize. So those 3 Ds that we always talk about, we need to think about them all the way down in our smart meter story. Otherwise, how will the prosumer participate and be in the center of it if his smart meter or his access is not allowing it?
As I mentioned, all the efforts I mentioned also in relation to the cause I said before are aimed to this scope. So enable platforms in making available data to all the actors in a smart grid. So with the result of the calls, and we aim to test what they propose. So because the first thing, we have an idea of how should be the smart grid of tomorrow, but we have to test. First thing to test, to validate, and then for some other aspects, we're talking about electricity grid. It has to be linked also to the gas system. Clearly, electricity grid is it's not a simple system. It's a critical infrastructure. So clearly, there's the need to de-risk some technologies before applying them directly to the grid. And we can do that. Horizon 20, the project under Horizon 2020 and the next framework program Horizon Europe from 2021 to 2027 in discussion actually, will help in this sense to develop these new technologies.
So, any more comments here from the floor? Any questions from the floor? Last stop. Yeah, very good. Lovely.
In fact, a few questions. My name is Pinkas, I'm from Poland. Firstly, I would like to discuss only gas, because for electricity, the business model is very clear. I mean, only arranging the grid better, yeah, to make it more efficient is a very good goal. But taking into account the situation of Poland, where is a monopolist gas utility, what interest, real interest, would be for gas utility to make customer using less gas if the gas utility is selling gas and making profit on gas selling? So if we deliver the smart meter would help customer to use less gas. Being monopolist gas utility, I would not implement smart meters. Of course, yeah, from business model point of view, of course you can have less people reading the meters, so gaining some other efficiency, but from giving the data to the customer to decrease the consumption would be killing my footage. So this is a tricky question, so I would like first perhaps France, yeah, because you use also you are dealing with gas.
For us, this is not a question. I think we have to take part to the energy transition, so we take it as a goal. So, and we do not sell, as GRDF, we do not sell any gas. Of course, we transport it, and it's part of our business model. But if you think about our business model, we still have to deliver energy to the consumer. So what has to be changed is maybe the structure of the tariff. We'll have a fixed part increasing and a variable part decreasing. But for us, achieving energy savings is not a question. We do not have the choice. We have national objectives, and we just ask them how to participate to these goals and how to adapt our model. So we take the problem differently. We say, okay, we have to do it, and how to create value around this, and how to, in the meantime, we try to develop new gas usage. For example, mobility with gas. We also try to still develop gas usage by replacing natural gas with green gases to fit with energy transition and low carbon goals. So we take it as part of a wider problem, and we try to find different solutions, but for us this is not a question. We think energy savings, we have to achieve them, and we have to comply with the national objectives. But I understand your point, but that's it.
I have another tricky question. A base for smart metering was in general environment protection, so decarbonization. Where I made this investigation, and it seems this was a main goal for Europe to decrease influence on the environment. However, my question is, I have read also and saw some movies in internet showing the problem of increasing radio pollution due to IoT business. And this is very much pointed. I believe there is an even organization showing the dangers of so big pollution by radio. How do you deal with this, or do you think about that? And do you, let's say, plan also to decrease the radio pollution in the environment of the future cities?
Do you want to add something? I have a gas power infrastructure expert with me, and we deployed a solution called 169 megahertz. And for that solution, I suggest to give you an answer, but I think it depends on the telco solution we use to collect the data. Maybe Alexandre?
So, in fact, in France, what we built was our own RF network. In fact, it's very, very low energy, because in fact, it all comes from a requirement. In fact, our metrological life for the meter is 20 years. So we needed to have a solution that transmits the data during 20 years without maintenance and at the lowest cost possible. So what we designed was a solution that was very efficient. The transmitted power is roughly 50 milliwatts, and it transmits around 100 milliseconds twice a day. And so that allows the solution to last 20 years with just 2 AA lithium batteries. And so in fact, the radiated power is very, very low. In fact, it's the same as if, for example, if you have a parking, you have a remote control of your parking door. And in fact, you just push and it's the same. You do it once in the morning to go out, you do it once in the evening to go inside your garage, your parking. And so in fact, we radiate exactly the same. So for the consumer, it's something that it can understand, and so it doesn't fear the radio from our gas meter today. That's the main point. In fact, I agree that it's one more thing to transmit, but it's really, really low, and in fact, it's quite invisible because 50 milliwatts when you're not just around your meter, when you are 2 or 3 meters away, it's just not possible to measure. There's no impact on everything, in fact. I don't know if I answer your question.
Yes, thank you very much.
So, I think we should stop here. The time is actually out. We had a fantastic panel. I was really enjoying it. I hope you did as well. I hope you enjoy listening to this whole session. And with that, I would like to thank you all and close this session. Thank you.